Hello dear students, in today's video we are going to discuss about the derivation of the three equations of motion. We already discussed that. Which are the three equations of motion? V is equal to, the first equation is V is equal to U plus AT, and the second is equal to, second equation, S is equal to UT plus half AT square, and the third equation is V square is equal to U square plus 2AS. So in today's video we are going to see how these equations can be derived from the graph. So I am explaining it in short. So if you got any doubt, you just watch this video again. Okay. So these are the three equations. How can we derive these three equations from a graph? Suppose we are considering a uniform motion of an object which is moving from, suppose, a point A to B. Suppose if it is undergoing uniformly accelerated motion. So here you can see I have drawn a graph that represents this particular motion, where one more few things we need to remember here. Initial velocity of the object is not zero, and here OC represents time, then OE represents final velocity, OA represents initial velocity. Look at these things again. OA, from the point O is the origin and the point A. At the point of consideration, the object is traveling with certain velocity. Say for example 10 meter per second. So that's why we are mentioning initial velocity is not zero. So this is an example of uniformly accelerated motion. So already we have seen the graph of uniformly accelerated motion, which is a straight line inclined at an angle with the axis. So here we can see the AB is the graph of an object moving with a uniformly accelerated motion whose initial velocity is not zero. And here we can see OC is the time T. Then suppose on the right hand side, if you look at the right hand side, you can see this graph this portion just look like a rectangle. So here BC will be equal to OE. So OE is actually, this is the initial velocity and this is the final velocity, this point. So the corresponding, if you drop a perpendicular to the y-axis, here you will get the final velocity. So the distance OE is known as the final velocity, OC is known as the time, and OA is known as the initial velocity, U. So the corresponding, we can, OA will be equal to DC, and at the same time we can see OE, that is final velocity, that will be also equal to BC. What will be BD? BD will be equal to this distance, BD will be equal to BC minus CD. So, and OC is equal to T. So, again we can see what is BC. BC is equal to final velocity V, and CD is equal to OA, that is initial velocity, that is U. So, we can write BD is equal to V minus U. So, in the previous equation we already seen that acceleration is change in velocity upon time. So substitute this value, A is equal to what is change in velocity? V minus U. So that we are writing BD divided by time. What is time? OC. BD by OC. Or we can, if you write, A will be equal to acceleration, A will be equal to what is BD? V minus U divided by T. Or you will get this particular equation. Or from this equation we can write what V is equal to. We are taking this equation again, you can write this way, AT will be equal to V minus U. Then we are taking V to the left hand side, then we will get the first equation, V is equal to U plus AT. So this is the first equation of motion. Then we are moving on to the second equation of motion, in which there is one distance time relation. The first equation is known as the velocity time relation, second equation is known as the distance time relation, and third equation is known as the position velocity relation. So in the second equation, distance time relation. So here we need to calculate distance travel S during this particular interval A to B, or during the journey of our object from the point A to B. See, similarly we can see, we already seen that in the previous equation, previous graphs section. In the case of uniformly accelerated motion, we can find the total distance traveled by the object by calculating the area of the triangular portion plus area of this rectangular portion. The sum of these two areas will give you the total distance traveled by the object. So, see, you can see area of the rectangle plus area of the triangle. So, what is area of the rectangle? Here we can see length into breadth, OA, that is taken as breadth, then OC we are taking as the length. OA length, area of the rectangle is length into breadth. Then what we can see, OA into OC plus area of the triangle, that is half into base into height. What is your base? AD, then height is BD. Then substitute the value, already we have got AD is equal to T. AD will be equal to OC. These two are same as their opposite sides of the rectangle. Their length will be same. So AD will be also equal to T. And one more thing we need to look at that BD we already derived. That is, what is BD? BD is equal to V into T. BD is equal to, sorry, A into T. This particular equation. So that this value we are substituting here. Here we can see what is V minus U. V minus U, that is BD, or AT we can also write as equal to BD. AT we can write as BD from this particular equation. Then substitute this value of BD as AT here, then you will get S is equal to UT plus, here OA stands for U. OA, that is the initial velocity, that is breadth U, then length OC, that represents the time, then plus half, then AD into BD. Here BD already we got AT. Instead of BD we need to substitute AT, then instead of AD we have to write T. Then you will get A into T square. So this equation is known as the second equation of motion. Then we are moving on to the third equation of motion. So here also we are going to consider this equation is also known as the position velocity relationship. Here also we are considering the calculating the area of this particular region. So if you consider a triangle or a rectangle, so this particular figure that will remain just like that figure is known as trapezium. So how will you calculate the area of the trapezium? That is sum of the opposite side into height divided by 2. So here you can see, substitute the value, S is equal to OA plus BC into OC divided by 2. That is the equation for calculating the area of the trapezium. Substitute the value, that is OA. OA is U. Then BC, the value of BC is V into OC. What is OC? OC is time. T divided by 2. So now look at the first equation. What is acceleration? A is equal to V minus U upon T. Or we can also write from this equation, T is equal to V minus U upon A. So this value of T we need to substitute in the place of T here. So we can write this equation as S is equal to V plus U as it is. Just interchange that into, instead of T you need to write V minus U divided by 2A. This acceleration A comes over here. Though now we are taking this 2A from the denominator to the left hand side. So what will become 2as. It will become 2as, that is equal to this particular form. This form is in which form? VA plus B into A minus B. This is in the form of what is the short form? V square minus U square. So we can rewrite this as 2as is equal to V square minus U square. Use that particular identity. A square minus B square is equal to A plus B into A minus B. So we will get, while rearranging this particular equation, you can get V square is equal to U square plus 2as. This is our third equation. So I hope you understand this particular portion. It's little bit difficult. You watch it again 2 or 3 times so that we can understand it well. Okay, study well, keep studying well. Okay, thank you.